So the go back in ARQ. What are the features and the properties of this protocol? We mentioned that this protocol is used in order to solve some of the problems that exist in stop and wait ARQ. One of the key problems that exist in stop and wait ARQ is not good utilization of the bandwidth, available bandwidth, because it sends only one frame at a time. And therefore, the performance of it, especially the throughput performance, is not that good. To solve or mitigate this problem a little bit, we use a concept called sliding window. The key idea behind this concept is to send multiple frames at a time. And one of the protocols that utilize this concept, sliding window concept, is go back in ARQ. So what's go back in ARQ? What are the properties of go back in ARQ? First, this protocol uses the concept of pipelining, which means the sender can send multiple frames before receiving the acknowledgement for the first frame. This is the key difference between go back in and the stop and wait ARQ. So if I ask you in the test that you will see at the end of this course, what's the difference between stop and wait ARQ and go back in ARQ? You tell me the first difference is in the usage of sliding window concept. And this means that the go back in uses pipelining concept. It sends multiple frames before receiving an acknowledgement for the first frame. It doesn't wait for each frame individually to receive its ACK or NAC. Second, this protocol, there is a finite number of frames, and the frames are numbered in a sequential manner. It's not infinite number of frames, finite number. The number of frames that can be sent depends on the window size determined by the sender. If the acknowledgement of a frame is not received within an agreed upon time period, all frames in the current window are transmitted. This is one key point here to mention, and I just wrote it here in bold. So let's say now you tell me, okay, we understand that this protocol improves the throughput. Why it improves the throughput performance? Because it doesn't wait for an ACK. It doesn't wait for receiving an ACK for each frame individually, but rather it sends a bunch of frames, let's say 5 frames together, and then waits for their ACK or NAC and continue sending after that. But yeah, I understand this can improve the throughput, but unfortunately, if one of the frames within the sliding window was received in error, was not received correctly by the receiver, then all the frames in the current window are retransmitted again. All the frames, the ones after and before the error. So this key feature of go back in ARQ creates another problem, which is also bad utilization of bandwidth. Why? One clever engineer might ask this question: why should I ask the transmitter to resend frames that I already received correctly, but just because one of the frames neighboring to them was received in error? So this is the key problem. You have sliding window. This sliding window has 5 packets. Let's say the first one, second one were received successfully, but the third one was received in error. The fourth and fifth were received successfully. But because the third one was received in error, the transmitter will have to retransmit all the frames within this sliding window, regardless of whether they were successfully received or not, just because one of the frames was in error. So of course, any clever engineer can see that there is inefficiency here in the protocol. It's not fully utilizing the bandwidth, and it's not giving us, it's not really fully utilizing the available bandwidth in a wise manner. So in sender window size, for example, if the sender window size is 4, then the sequence number will be 0, 1, 2, 3, and again 0, 1, 2, 3, and again 0, 1, and so on. You continue. The number of bits in the sequence number is 2. The number of bits in the sequence number here, since you are the sequence number here, the code of it depends on the number of frames and your window size. If your window size is 4, how many bits you need to represent sequence numbers? You need 2. If the window size is 8, how many bits you need to represent each sequence number for each frame? 3, and so on and so forth. So this can be also a potential question here, how you can do these things. So this is basically what go back in ARQ. The main 2 points I want you to understand in this, the most important 2 ones, are the following. First, this protocol sends multiple frames at a time. It doesn't wait for the ACK individually for each packet. And if an error occurs for one of the frames within the window size, all the frames within that window should be retransmitted again. So these are the key differences from stop and wait ARQ.